Good morning, students. So, in this video, we are going to see about temporary over voltages, which are again nothing but lightning and switching over voltages. So, kindly go through this video. Thank you.
Hi friends, this is my fifth lecture of power system series, and in this lecture we are going to discuss over voltage in transmission line. So friends, there are basically two main reasons for over voltage in transmission line. First is lightning over voltage and second is switching over voltage. First we will discuss lightning over voltage. You all must have seen lightning across dense dark clouds in rainy season. Friends, have you ever wondered why this lightning phenomena occur? Today I will explain it to you that why lightning phenomena occur. See, these clouds are made up of small drops of water. Now due to low temperature at height, these droplets of water are converted into ice crystals. Now when these ice particles rub against each other, then they get charged. And this charge is called cloud charge. So if some other cloud comes near this charged cloud, then there is transfer of charge between these two clouds. And this transfer of charge is responsible for lightning phenomena. So that's why lightning phenomena generally occur between clouds, because this charge transfer take place between clouds. But sometimes this lightning reaches the earth, or when this lightning reaches the earth, then it is matter of concern, because we have transmission lines on earth. But you may ask, why we hear sound during lightning? So answer is, when lightning strike occurs, then it create hole between clouds, or we can say it create space between clouds. And this space is created to transfer the charge between clouds. So when charge transfer is completed, then air rushes to fill, or we can say air rushes to occupy the space created. So this rushing of air to occupy the space is reason for sound. So this sound is due to rushing of air to fill the vacuum or space created by transfer of charge. Now tell me in comment box why we see lightning first and hear sound after some time when lightning occurs. Okay, so you have to answer this question in comment box. Now come to the topic. When this lightning charge reaches, or we can say when this lightning charge strikes the ground, then it may damage our transmission line. Because when this lightning strikes the transmission line, then it transfer its charge to it. Okay, or we can say charge is transferred from lightning to our transmission line, and we know that voltage is directly proportional to charge. That's why lightning is responsible for over voltage in transmission line. Below 345 kilovolts, insulation level is directly proportional to the lightning over voltage. Or we can say that below 345 kilovolts, insulation level is decided by lightning over voltage. Now we must protect our transmission line from over voltage. For this, a conducting wire known as ground wire is used at the top of transmission line tower. Ground wire is at the top, so it provides lowest resistance path to the lightning charges. These lightning charges on ground wire, they are transferred to the ground through metallic body of tower. Now we will discuss another reason for over voltage, and that is switching over voltage. Let's understand this. We know that when there is a fault, then circuit breaker operates and its contacts separate. When contacts of circuit breaker separate, then it behaves as a capacitor, because contacts of breaker are metallic and space between contacts act as a dielectric medium. Now these separated contacts and the inductance of line, they together form LC circuit, because this separated contact act as capacitor and line act as inductor. So they in combination they form LC circuit, and expression of voltage for LC circuit is V is equals to Vs in bracket 1 minus cos omega naught t. This expression has already been covered in my previous lectures, that is in my videos of power electronics. So you can visit my lectures on power electronics. There you will get the derivation of this expression. So here in this expression, V is equals to Vs in bracket 1 minus cos omega naught t. Omega naught is equals to 1 by root LC. So the maximum value of voltage from this expression is 2 Vs. And 2 Vs will occur when cos omega naught t is equals to minus 1. So maximum voltage is 2 Vs. And this maximum voltage, that is 2 Vs, is responsible for switching over voltage. So the voltage rating of transmission line greater than 345 kV, the insulation is decided by switching over voltage, or we can say that insulation is directly proportional to the switching over voltage. Now this is all about over voltage in transmission line. I hope you got my point. If you got some knowledge and concepts from this video, then please subscribe the channel and press the bell icon. Thank you.
So in this video, we saw about the temporary over voltages that are of two types, lightning as well as switching over voltages. In the next class or next video, we are going to see about corona and its effects. That is, what is corona? You might have studied the same thing in your transmission distribution. So once again, we are going to see in a detailed manner here. So thank you so much. Thank you.